Hello everyone and welcome back. So I have a few tests here, a few wedges testing different values, and this one is about the expansion rate, which we looked at to inject divergence, and this test has a injection rate or an expansion rate of 1, expansion rate of 2, expansion rate of 6, and expansion rate of 4. And you can see we're getting more and more smoke emitted and injected into the sim. Now you can clearly see all these boxes issue, and unfortunately it's not ideal. Okay, so the next one, I have a test for the temperature amount, and this is the value 0.1 for the temperature. This is a value of 1, and this is a value of 10, and it may look like it's injecting more temperature, but it's not. It's increasing the temperature value. It's not emitting it more. And when we increase the temperature, it's gonna cause the smoke to move up higher, and it's gonna obviously it's brighter, so it's gonna look more white across the board, so we have to tweak it. But that value is not adding more temperature, it's increasing the temperature, which will then affect the movement of the sim and change the way it looks. Smoke amount. The next test is smoke amount, and this is when we have add smoke. And if we compare most of these, especially this and this, they're almost identical. This is 10 and this is 100, and they are very close to this as well, and this is a value of 1. Because the density is used as a multiplier in few nodes, the range or the density value itself is going to affect the sim, but that multiplier, that amount, is not adding more smoke. Okay, it's just multiplying the density value. So this smoke here is 10 times denser. This one is 10 times denser than this. This one is 10 times denser than this. That's it. That's the ratio. The result of that is going to be visible in the sim as motions, because we're using that density to drive various other things. Okay, but the sim itself or the control is not doing that. It's us when we create a gust, turbulence, or dissipate or shred, and we use the density as the driver. That's gonna affect or change. So that's why we see effect on this. The next one is the flame lifespan, and this is simply going to have whatever value we give it, it's gonna live longer. So this one is value of 2, this is 4, and this is 10, and this is 20. And you can see the flame is rising up. Well, it's not rising up higher, it's living longer, and then because of the temperature and all that, it's rising up higher. Okay, so we have to be very aware of these things, because we're not adding more flame. It's not the value of the flame itself is not stronger, it's just it lives longer. So basically the dissipation of the flame is lower, it dissipates less over time, and that doesn't mean the data itself is changing, it's just it lives longer, which will then be propagated into the sim and change it as well. And then one important test I wanted to show was the swirl size of the turbulence, and this is the visual I was looking for. I wanted to have that main smoke be so turbulent at a large scale, not a small scale. I didn't care too much about the small details. Okay, so this is a value, a swirl size of 5, and it's very close or very similar to what I was looking for. This is a value of 20, which I still like. It's large, it connects everything together, and this is a value of 10. So I wanted to show how that would look like, and with this knowledge we can now start setting up our networks. We can create the source and start creating stuff. So thank you guys for watching, and see you in the next video. Bye bye.